In the previous video, we looked at modifying the intensities of the image pixels to enhance the contrast by using histogram equalization. In this video, we're going to take a look at corner detection for image analysis, which will eventually enable us to identify the salient points in the image. We'll also learn to detect SIFT feature and use it for image recognition and content analysis. Corner detection is an important process in computer vision. It helps us identify the salient points in the image. This was one of the earliest feature extraction techniques that were used to develop image analysis systems. Let's create a file, cornerdetector.py, and then import these packages. Let's load the input image. Here we will use box.png. Now convert the image to grayscale and cast it to a floating point values. So we need to read the floating point values for the corner detector to work. Next, run the Harris corner detector function on the grayscale image. You can learn more about Harris corner detector at docs.opencv.org. You'll surely find some useful stuff here. Let's go back to our editor. So this is the line of code we inserted for Harris corner detector function. Now, in order to mark the corners, we need to dilate the image as this. Let's threshold the image to display the important points. Finally, let's display the output image. Let's go ahead and run this file. When you run this file, you get two images. The input image is displayed on your screen, which you see on the left. So let's move to the next topic, i.e. detecting SIFT feature points. While the second one is the output image obtained after detecting corners. Now let's have a look at SIFT features. Scale invariant feature transform, i.e. SIFT, is one of the most popular features in the field of computer vision. David Lowe first proposed this in his seminal paper, which is available at this web link. It has since become one of the most effective features to use for image recognition and content analysis. It is robust against scale, orientation, intensity, and so on. This forms the basis of our object recognition system. Let's take a look at how to detect these feature points. Let's create another new Python file, and we name it featuredetector.py. Then we go ahead and import these packages. Now load the input image. We'll use table.jpg. Next, we convert this image to grayscale. Now initialize the SIFT detector object and extract the key points. The key points are the salient points, but they are not the features. This basically gives us the location of the salient points. SIFT also functions as a very effective feature extractor, but we'll see this aspect of it in one of the coming videos. Now, draw the key points on top of the input image in this way. At last, display the input and output images. Let's now run the code and check the output. So, we have the first image, which is the input image we provided, whereas the second one is the output image with the SIFT features. Wonderful! In this video, we have learned how to identify the salient points in the image by detecting its corners. Also, we have obtained and detected the SIFT features for the input image provided by us. In the next video, we'll see how to detect SIFT feature points.